Welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is exponents, the negative exponents property. Let's get prepared. Bring a pencil with an eraser so that we can take notes, and we'll need some paper to write those notes on, as well as a calculator. It's optional and not required, but if you'd like to self-check yourself, it could be useful for that. Don't forget to pause the video from time to time to answer the practice questions and rewind the video if you need to review anything before trying to answer the questions. All right, let's go over our Grow Your Vocabulary. But before we do, let's go ahead and do our 3 breaths. So we're going to try to forget all of the thoughts that are in our mind that might be getting in the way of our learning. We're going to breathe in through our nose, hold it for a count of 3, and then breathe out our mouth. So let's go ahead and do that first. Hold it for 1, 2, 3, then breathe out your mouth. Breathe in your nose. Hold it for 1, 2, 3, then breathe out. Okay, one more time. Breathe in your nose. Hold it for 1, 2, 3, then breathe out. Good. All right, at any time if you want to stop the video and do some more breathing exercises just to kind of clear your head, by all means, pause the video and do that. Also, you may want to rewind and rewatch a few things after clearing your brain out because you may have missed some things. Okay, let's go ahead and look at our vocabulary. We have this awesome quote here that says, "Math is the only place where truth and beauty mean the same thing." And I definitely agree with that. And the more you study math, the more you start to realize how true that statement is. Okay, oops, didn't mean to do that. We're going to go into our first word, which is exponent, and that is the shorthand that we use to describe how many times to multiply a number times itself. Power is what we call an exponent. If we raise a number to the power of 2, for instance, that means we're going to multiply it times itself, and there are only 2 terms. If we raise it to a power of 3, that means we will multiply it times itself and then times itself again, and there will be 3 terms. A base is the number that the exponent is attached to, and then negative exponents property is what we're going to be discussing today, and that's how do we deal with negative exponents? How do we work with those? Zero exponent property is just as a review. Remember that any number raised to the power of 0 is equal to 1. The exception to that rule is 0. You cannot raise 0 to the 0th power, but any other number that's not a 0, when you raise it to the 0 power, it equals a 1. Expanded form and exponential form. The expanded form is when we actually multiply the number out with all the terms, and exponential form is when we write the number with the exponent attached. Reciprocal is when we take a fraction and we flip it around where the denominator becomes the numerator and the numerator becomes the denominator. Multiplicative inverse is when we multiply 2 reciprocals together, and a reciprocal, when it's multiplied times, when reciprocals are multiplied, they end up being a 1. So multiplicative inverse means I multiply a fraction times its reciprocal, and I end up with an answer that's a 1. Okay, negative and positive, that's when we work with integers. Remember, integers are all whole numbers that are negative and positive with 0 in between. If you're looking at a number line, the positive numbers would be on the right and the negative numbers would be on the left. And variables are those letters that we use in algebra to describe quantities that are unknown. Lesson essential questions. The first one is, what is a reciprocal and what is a multiplicative inverse? Explain the negative property of exponents. How do you cancel out a negative exponent? And then what is the understood exponent of a number that has no exponent? All right, so let's review what are exponents. If you have watched the previous videos in this series, then you have already seen some of this information, but it's good to review it. Exponents are a shortcut for repeated multiplication, just like multiplication is shortcut for repeated adding. Exponents tell us how many times to multiply a number times itself. Exponential form is what you're looking at here, where you have the base with the exponent attached. And expanded form is when we actually multiply out the numbers. Exponents shorten having to write out long expression of factors. So it is good. And don't forget to watch out, because a lot of times students forget that you do not multiply the base times the exponent. The exponent is merely telling us how many numbers to write in our expression to multiply. So if there's a 3 here, then I know there's going to be 3 5s that I'm multiplying together. All right, let's look at, when there's no exponent. All right, so when there's no exponent showing next to the base, then the exponent is a 1. It is often necessary to write, it is often not necessary to write the 1 exponent. But if the number or the base stands alone, then it is always an understood exponent of 1. Okay, so we work with positive numbers all the time in elementary school, and we don't realize it, but all of those numbers that just stand alone technically have a 1 exponent attached to them. We just don't write that. Okay, but if you're using it to add, subtract, multiply, or divide exponents, sometimes knowing that is useful. Let's look at some examples. 8 to the first power is the same as just 8, and 7 is the same as 7 to the first power. All right, 0 exponent, again, we've reviewed this before, but let's go over it one more time. A 0 exponent means that the answer would be 1. The only number that this doesn't work with is 0, okay? So 8 to the 0 power is a 1, negative 1/3 to the 0 power is a 1. Anything to that 0 power is always going to simplify down to a 1. So if you know that and you have a very complicated expression and all of it's, raised to the power of 0, then you know that that complicated expression is just going to end up being a 1. All right, so exponents in parentheses, we have reviewed this once before, but let's go ahead and review it again. Powers can have both positive and negative bases. So here we have an example where we have a negative 4 with a exponent of 2, and when the negative is not in a parentheses here, then that's the same as saying negative 1 times 4. Okay, negative 1 times 4 is how we would break down that negative 4. And then we're only squaring the 4. We're not squaring the negative 1 there. Okay, so it ends up being in expanded form a negative 1 times a 4 times another 4. And because of that, our answer is negative. So when there's no parentheses, you're always going to end up with a negative answer when you multiply that out. When there is a parentheses, sometimes it's negative and sometimes it's not. It depends on what your exponent is. So if I have an exponent of an even number, like this 2 here, then I'm going to take the entire negative 4. It's not going to be negative 1 like this one. It's just going to be the whole negative 4, and I'm going to multiply it times another negative 4. Okay, and that's going to give me a positive 6. So when the exponent is an even number, our answer will be positive when there's a parentheses around that negative base. When there's a parentheses around the negative base and the exponent is odd, then our answer is going to end up being a negative answer. Okay, so let's review reciprocals and multiplicative inverses. A reciprocal of a number is to take a fraction form of the number and flip the numerator and the denominator around. Then we multiply the reciprocals together, and when we do, the product will always be 1. This is called the multiplicative inverse. Okay, so you don't always have to multiply reciprocals together, but that's the definition of this multiplicative inverse here. Okay, so here's just some examples of reciprocals. 2/5, when you flip it around, becomes 5/2. 6 is the same as 6/1, or 1/6 when we flip it to its reciprocal. Remember, whole numbers, you just place over 1 to turn it into a fraction. 1 3/4, we turned that into a mixed number by multiplying. This is my little around the world strategy. Multiply and then add. So we're going from the bottom, going around the world. And when we do that, we end up with 4 plus 3, which ends up being a 7. And so 7/4, when I find the reciprocal, ends up being 4/7. So reciprocals are just when we flip numbers upside down that are in fraction form. A reciprocal that is a multiplicative inverse is shown here. So anytime we take a number and we flip it around to its reciprocal and then multiply them out, you're always going to get a 1 for the answer, okay? Let me show you how this works with these. So 5 over 3 times 3 over 5, that's technically 15. Ooh, I did not mean to do that. Let's see, let's try that again. That's technically going to be 15 over 15. Because 5 times 3 is 15, and then 3 times 5 is 15. And 15 over 15 does simplify down to 1. So just remember that anytime, like here's some examples of this, anytime you multiply it times a reciprocal, you're like this would be 12 over 12, which is still a 1. Or 7 over 7, which is a 1. It's always going to end up being a 1. Okay, so here is our negative exponents rule. Now, this is an important rule that I typically ask students to do at the very end of simplifying expressions when you're simplifying more complex exponential expressions, which is in the next video called Simplifying Exponential Expressions. So to cancel out a negative exponent, you need to change the base to its reciprocal and then remove the negative sign. Okay, so that's why knowing what a reciprocal is important when it comes to negative exponents. So here's some examples. A to the negative n power. Remember what I said in a previous video on exponents. When you're simplifying exponential expressions, the negative should not be in your final answer. If it's going to be in simplified form, the negative on the exponent needs to go away. Now you can have a negative base, but the exponent should not be negative in your final answer. So to get rid of that, we basically need to take our number, turn it into a fraction if it's not already a fraction, and then flip it around. And when we flip it around to its reciprocal, that negative on the exponent goes away. Okay, let's look at another one. 3 to the negative 2 is 3 over 1, right? If we turn that whole number into a fraction. So flip that around and you end up with 1 over 3 squared, okay? This one is a fraction to the power of -6. And so when we flip that fraction around, that -6 becomes a +6. Okay, here's some more examples. Let's look at 2 to the -3, okay? Place the 2 over a 1, turn it into a fraction, then flip it. And then if we actually reduce this down to the most simple form and expanded form, not exponential form, 2 times 2 times 2 ends up being 8, so we end up with 1 over 8. The second example here, 4 to the -2, place that 4 over 1, turn it into a fraction, flip it, and then again, simplify that 4 squared down. 4 times 4 is 16, so our answer is 1 over 16. 5 to the -3 divided by 2 to the -4. Now here's where it gets a little more complex. Okay, if I took that 5 to the -3 and not counting the 2, okay, not counting the 2, that would technically be 5 over 1 to the +3, okay? But this 2 is on the bottom, so here's where it gets a little more complex, okay? When I flip this 5/2 to its reciprocal, not only does it make the -3 go away and become a +3, but if the negative is also on an exponent in the denominator and you move it over the division bar up to the top, that negative that's in the denominator is also going to turn positive. So if you have a -3 in the numerator, move it to the denominator and that negative will go away. Same with this. If you have a negative exponent in your denominator, move it to the negative and it will go away. You can list this out when we do the simplifying exponents video. You'll see a lot of examples of this kind of thing going on, okay? So now that we know about this being positive and this being positive, we can multiply all of those out. 2 times 2 times 2 times 2 is 16, and then 5 times 5 times 5 is 125. Okay, variables are often used with exponents in mathematics too. So b to the -8 ends up being b to the +8 over 1. And then when we flip it, I'm sorry, that should be negative up here. That should be a negative. b to the negative 8 over 1. And then when we flip it, that negative went away. Okay, that negative on our original problem went away. And then here's some evaluations of expressions here. We have 3 to the negative 4. Again, we're going to place that over 1, flip it, and we end up with 3 to the positive 4, or 3 times 3 times 3 times 3, which is 1 over 81. Here, the negative is in the denominator. We flip it to the numerator, which is going to make this 2 to the 5th over 1, which is just the same as 2 to the 5th. And that ends up being 2 times 2 times 2 times 2 times 2, which is also 16 times 2, which is 32. Let me write that down for you, 32. Whoops. Well, my pointer is not wanting to work for me today. There we go. Alrighty, now let's go to negative exponents rule with products and quotients, okay? Look at these examples of using the negative exponent property in multiplication and division problems. So let's look at these words. A power with a negative exponent equals 1 divided by that power with its opposite exponent, or the positive exponent. So here's some examples. This is similar to what we just did on the previous slide. And so let's look at some of these problems. We have C to the negative 6th power and D to the 15th power. Now in this case, when I place everything over 1, the only negative exponent I have is on the C, not the D. So I'm going to leave the D in the numerator and only move the C to the denominator. Now, when I do this, the 1 does go back to the top, but we know that 1 times any number is just itself. So you don't really need to write the 1 times D to the 15th over the C6. That 1 times D 15th is just going to reduce back down to D to the 15th. Okay, 2 to the 3rd divided by 7 to the negative 2nd. Again, we can flip that fraction around, but since this is already a positive exponent, we don't want to flip the 2. We only want to flip that 7 to the negative 2. So we're going to move that up to the numerator, and now the negative on this 2 has gone away. And so we can just multiply everything out. So 2 times 2 times 2 is an 8. And then 7 times 7 is 49, and 8 times 49 is 391. All of this is over 1, but we know that any number over 1 is just itself, so we reduce it that way. Okay, here's 3 to the negative 2, and this time instead of a division problem, it's another multiplication problem like the one we had here. So 3 to the negative 2 times 2 to the negative 5 is going to be equal to 3 to the negative 2 over 1 times 2 to the negative 5 over 1. So we place them over 1 to turn them into fractions first. Then we flip them, and it would be 1 over 3 squared times 1 over 2 to the 5th power. That ends up being 1 over 9, because 3 times 3 is 9. And 2 times 2 times 2 times 2 times 2 is 32. So 9 times 32 is 288. And so our final answer is 1 over 288. Then we have some variables here that are being divided. Again, we have a negative in our numerator and a negative in our denominator. Now, if we know our negative exponents rule, we can just flip it around, okay? So the E goes to the denominator and the exponent becomes positive. The F is negative 3 in the denominator, so when we move it up to the numerator, the negative goes away there, and that's our final answer. Okay, now it's your turn to try and grow a blossom. So simplify the following exponential expressions and write your answers in exponential form. So go ahead and pause, and I will count to 3 and see if we can answer these on our own. 1, 2, 3. Okay, so the first one here, the answer is going to be 1 over 7 to the 6th power. So again, we place this number over 1 because it's a whole number, and then we flip it to its reciprocal and get rid of that negative exponent when we do that. We left our answer in exponential form because that's what it said to do in our directions. And so the second answer is going to be a to the 8th power over 1, which just reduces down to a to the 8th power. So right now it's in the denominator. When we move it to the numerator, the negative goes away, and we know that any number over 1 is just itself, so it reduces down to a to the 8th power. Okay, try to grow another blossom. So let's try to do these on our own. Simplify the following exponential expressions. So I'm going to ask you to pause, and I will count to 3. 1, 2, 3. Okay, so with this expression, we place both of these over 1. And then since they both have negative exponents, we're going to flip them around and place the 1 on top, but the m to the 5th and the b to the 2nd is now positive. And we cannot reduce that anymore. Okay, the second one, 2 to the negative 3 times 3 to the negative 4, we're going to place those numbers over 1, turning them into fractions, then flip them around. The negative exponent goes away, and since it did not tell us to place our numbers in exponent form, we're going to multiply those out. So 2 times 2 times 2 is an 8, so we end up with 1 8, and then 3 times 3 times 3 times 3 is 81. So 1 times 1, when we multiply across, is a 1. And then multiply your denominators across, and you end up with 648 in your denominator. Okay, let's do a third math blossom. Simplify the following exponential expressions. And so let's go ahead and try to do that. Pause the video, and I will count to 3. 1, 2, 3. All right, so our first answer is g to the positive 4 over h to the positive 2. Again, when you have an exponent in the numerator, move it to the denominator. When you have an exponent in the denominator, move it to the numerator to get rid of those negatives. When you move an exponent, the base goes with it, by the way, because some people ask me that question sometimes. And then we have 3 to the negative 2 times 6. So the first thing we're going to do is turn that 3 and that 6 into fractions. So we're going to place those over 1, then flip them to their reciprocals, and the negative exponent will go away on this 2. And then we go ahead and multiply that 3 squared out, which gives us 1 over 9, and then multiply across the numerators, which gives us a 6. And across the denominators, which gives us a 9. This fraction 6/9 can be reduced again by dividing by 3 in the numerator and the denominator to obtain our final answer of 2/3. All right, our final, your turn to try and grow a blossom. Go ahead and simplify the following exponential expressions. We have c to the negative 3rd times d to the negative 4th divided by e. And remember, when there is no exponent on the number, there is an implied or understood exponent there. So keep that in mind. Okay, I'm going to pause, ask you to pause, and I'm going to say 1, 2, 3. 1, 2, 3. Okay, so basically, in order to solve this problem, we just needed to move c to the negative 3 to the denominator, and it's 1 on top, and d to the negative 4, and move that to the denominator, and the 1 stays on top. And of course, 1 times 1 is just 1. So we end up with c to the 3rd, d to the 4th, and the e did not move because it's got a 1 exponent, and that is positive. So we didn't want to move that one because it would be negative, and we don't want to leave those negatives out of our final answer. Okay, 3 to the negative 5 times a squared, b to the negative 8. Our answer for that is going to end up being a squared over 243b to the 8. So how do we get that? Well, 3 to the negative 5, we're going to place that in our denominator. So originally, I'm going to place all of this over 1, move the 3 to the 5th down. The a squared stays in our numerator because it is already positive on its exponent. Okay, and then the b to the 8, it's in the numerator when we place all of this expression over 1. So we need to move that down to get rid of that negative on the b to the 8. Okay, a squared is already simplified as much as we can get it, but the 3 to the 5th power, we can go ahead and multiply that out, which gives us a 243. B to the 8th, that's all we can do with that one. So we are all done. All right, so now let's look at our pause and answer the essential questions. What is the reciprocal, and what is a multiplicative inverse? Okay, so go ahead and try to answer those questions. All right, so what is our answer to this question? A reciprocal of a number is to take the fraction form of the number and flip the numerator and the denominator around. When we multiply reciprocals together, the product will always be 1. This is called the multiplicative inverse, and we do use those quite often when we're solving equations. Okay, what's the second pause and answer the essential question? Explain the negative property of exponents. In other words, how do you cancel out a negative exponent? So try to answer that on your own. Okay, the answer is to cancel out a negative exponent, change the base to its reciprocal, and remove the negative sign. So you're going to flip it around basically and remove that negative. So if it starts off in the denominator, move it to the numerator and get rid of that negative. Okay, if it starts off in the numerator, move it to the denominator and get rid of the negative. Okay, what is the understood exponent of a number that has no exponent? Go ahead and try to answer that one on your own. Of course, when a number or a variable has no exponent, that means the exponent is a 1. We typically don't write it, but if it helps you to write it down until you learn, that's perfectly fine. All right, let's go ahead and review our vocabulary one last time. This time we have a cute little fox who's going to help us out. Oh my gosh, how adorable is he? All right, so our first word is exponent, and that is a shorthand that we use to determine how many times we multiply a number times itself. A power is when we use exponents. We call them powers. When we raise a number to a specific exponent, we're raising it to the power of that number. And then the base is the number that we have the exponent attached to. And the negative exponent's property is when we take a number and if it has a negative exponent, we turn it into a fraction if it's a whole number, flip it to its reciprocal, and take that negative away. Zero exponents property means that every base that has a 0 exponent is going to be equal to a 1. Expanded form and exponential form. Expanded form is when we actually multiply the numbers out, and then exponential form is when we have the base written with the exponent only. Multiplicative inverse is when we take a reciprocal and take two reciprocals and multiply them together to create a 1. And then a reciprocal is a fraction that we flip around where the numerator becomes the denominator and the denominator becomes the numerator. Negative and positive numbers are integers as well as 0. And so when we work with those, we have to use our integer rules. Negatives always go to the left on a number line, and the positive numbers are on the right on a number line, with 0 being in the center. And then variable here is a letter that we use to represent a quantity that we don't know. All right, so great work. A bouquet of math blossoms have opened up in your mind today. So to further improve your math skills, remember to practice by doing your classwork and homework, study 10 minutes every day, ask for help if you need it from a study buddy or from your teacher, learn from any mistakes that you make, and always try. Okay, it takes patience to learn math, and it's a very good skill to have. It opens up so many doors for you. So I think that it's never a bad idea to learn math. And if you don't understand why we learn math in school, because I do have a lot of students ask me that, you should probably watch the Math Blossoms video on why do we learn math. Okay, I'm Miss G, and thank you for watching Math Blossoms today. Our next video in this series is simplifying exponential expressions, and it's very challenging. It's sort of a culminating activity with all of these exponent properties that we've been learning. So now it's time for me to say it was lovely teaching you math today. Bye.